In this tutorial on pH, we're going to find out what exactly pH measures. You're going to see how the ratio of H3O plus to OH minus plays the big role in determining whether or not a solution is acidic, basic, or neutral. You're going to take a look at the concentration of H plus in a variety of different solutions. As far as looking at the effective dilution, we might sort of touch on it here, but that will be touched on more in the in-class activity. And I will show you some examples of how to calculate the pH and the concentration of H plus in a solution. So pH is, simply put, a scale used to determine how acidic or basic a substance is. And the scale is based on it's based on a specific quantity of acidic and basic solutions known as the concentration of H plus or the concentration of H3O plus. And just note that this H3O plus is known as the hydronium ion, and it is essentially what one gets when you combine a proton with a water molecule. Here we have the hydronium ion. Most of the time, especially in this course, when I'm talking about pH or when I'm talking about the ion that an acid produces, I'll talk about H plus as opposed to H3O plus for the simple fact that it's simpler. It's simpler to say, simpler to write. But you need to understand that in reality, if you have an acidic substance, those protons that are produced in solution do combine with the water molecules to produce H3O plus. In figure 1, we can see that the pH scale is connected to not only the concentration of H plus, but also to the concentration of OH minus to a certain extent. And really, what determines whether something is acidic, basic, or neutral is about the ratio of H plus to OH minus. So for instance, if we take a look at a neutral solution here, so a solution with a pH of 7, pure water would be an example of this. The concentration of H plus in that solution is 1 times 10 to the minus 7, which is equal to the concentration of OH minus. So a couple of things to consider there. First of all, you have a neutral solution, but that neutral solution still contains some H plus. And so neutral solutions or solutions with pH of 7, they're not just pure water. They do in fact contain some H plus, but the reason that they are neutral is because they contain an equal amount of OH minus. The ratio of these two things is 1 to 1, which results in the neutral solution, because the H plus, which is responsible for more acidic properties, and the OH minus, which is responsible for the more basic like properties, I guess, the concentration of those two things is equal. So then if we see that for an acidic solution, like some of the ones we see down here, so lemon juice, for instance, has a pH around 2, a little bit less than 2. And so let's, for argument's sake, say that it's 2. So the concentration of H plus in that solution is 1 times 10 to the minus 2. But even though it's an acidic solution, there is still a concentration of OH minus in that solution with a value of 1 times 10 to the minus 12. So you can see that this number, the concentration of H plus, is much bigger than this number, therefore the solution is acidic. And the other way to consider this or to think about it is that for the lemon juice or for the solution of a pH of 2, the concentration of H plus in that solution is greater than the concentration of H plus in a neutral solution, therefore you have an acidic solution. Whereas for a base, and let's say something close to milk of magnesia, so which is used as a something to settle down your acid indigestion. So it's used as an antacid. So it has a pH of around 10, and the concentration of H plus in that solution is 1 times 10 to the minus 10, but the concentration of OH minus is 1 times 10 to the minus 4, meaning that there's much more OH minus in that solution than H plus, therefore the solution is basic. And again, we see that if we compare that to the value for a neutral solution, the amount of OH minus in that solution is much greater than what is in a neutral solution, or conversely, the concentration of H plus in that solution is much less than a neutral solution. Therefore, the solution with a pH of 10 is basic. So, digging a little bit deeper into figure 1, one of the things you may have noticed is that as the pH is increasing, the value, the concentration of H plus is getting smaller by a factor of 10 each time. So when I go from 1 times 10 to the 0, which is effectively 1, to 1 times 10 to the minus 1, which is written as 0.1, this value is 10 times larger than this value. And this value is 10 times larger than this value, and so on and so forth. That's because the pH scale is based on powers of 10, or it's logarithmic. And another scale that's like this would be the Richter scale. And so each movement on a scale that is logarithmic and is base 10 represents a change in the value, not just of 1, but actually a change by a factor of 10. What this does is it allows you to kind of condense some of the information so that you're taking a whole kind of wide array of values and making the presentation of those numbers a little bit neater, a little bit cleaner. But the big thing is, the most important thing is you understand that when you see a pH of 4, that represents an H plus concentration of 1 times 10 to the minus 4. And I'll show you how to calculate that down below. So if we have a solution that has, let's say, a pH of 2, okay, then we're comparing that to a solution pH of 4. So we take a look at the concentration of H plus for pH with a solution of 2 is 1 times 10 to the minus 2, and that is 10 100 times more or greater than a solution with a pH of 4, which means that solution with a pH of 2 is 100 times more acidic than the solution with a pH of 4. And the opposite would be true if we were starting with something that is more basic. And so let's say a solution with a pH of 12, and if we compare that to a solution with a pH of 8, so the solution with a pH of 12 is 10, 100, 1,000, 10,000 times more basic. So the solution with a pH of 12 is 10,000 times more basic, or 10,000 times less acidic than a solution with a pH of 8. And we can see that by focusing on their H plus concentration values, or also by looking at the concentration of OH minus for those two. So if you think of the pH scale as a number line, each time you move in this direction, where the value of the number increases, the pH is getting more basic. And as you move in this direction, where the numbers are decreasing, the pH is getting more acidic. And remember, with each step you take where you change by a unit of 1, and if we look over here, when we go from 0 to 1, that is a change in the concentration of H plus by a factor of 10. And in fact, that is a decrease in the concentration of H plus by a factor of 10 as our pH is getting more basic. Whereas if we move this way from 6 to 5 to 4, we can see now that with each step we take, the concentration of H plus is actually increasing by a factor of 10, and the solution is becoming more acidic. And finally, when it comes to calculating the pH of the solution, or calculating the concentration of H plus in the solution, there's two different strategies to use. So the standard formula for pH is pH equals the negative log of the concentration of H plus. And to calculate the concentration of H plus or H3O plus, remember they can be used interchangeably, you have 10 to the exponent negative pH. Now, depending on your experience in math, you may have come across some of these terms or expressions before. The thing I'm going to try and show you here is just how to do the calculation, but you're going to have to get comfortable with it on your computer. So let's say we have a pH of 2.34 and you're asked to figure out what the concentration of H plus is. So we are going to use this formula here, and you're going to enter that into your calculator in this way. So 10 to the negative 2.34. The thing that I want you to do is to actually enter this into your calculator and make sure that you get this answer, because every calculator has a different set of keystrokes that are required to properly enter this information. And so once you're able to get this answer, then you've done it correctly. Now our check here is probably the most important part. And the check says that the pH value is in between 2 and 3. And so what that tells us is that the concentration of H plus should be in between 1 times 10 to the minus 2 and 1 times 10 to the minus 3. Because you remember from the diagram up above that when we have a pH of 2, that corresponds to an H plus value of 1 times 10 to the minus 2, and a pH of 3 corresponds to an H plus value of 1 times 10 to the minus 3. And so the pH of 2.34 is somewhere in here, which should be in between these two values. And now to go in the other direction, from the concentration of H plus to the pH, if we were given a concentration of H plus of this, and you're asked to find the pH, then you have to use this formula. So you use your log button on your calculator. You take the negative log of this value. And so again, I want you to enter that information in and do so in such a way that you get the value of 10.4. And you may have to look for your log button on your calculator, but it should be there. All scientific calculators have it. And we do our quick check here, and we see that the concentration of H plus is in between these two values. So that tells us that the pH is in between 10 and 11, right? Because this value is bigger than 1 times 10 to the minus 11, but it's smaller than 1 times 10 to the minus 10. So, right, so it's in between those two. And since we know that this corresponds to a pH of 10 and this corresponds to a pH of 11, then the pH, we would expect the pH that we calculate to be in between 10 and 11, and it turns out that it is. And so our check makes sense. So the focus of this tutorial was to give you a sense of what pH is, how it's used, and what the nature of the scale is. And I hope I've been able to show you that there is this obvious connection between the concentration of H plus and the pH. And we can use some of those ideas when we're calculating to help us check our work, to help us check our answers, to see if things do in fact make sense.